Hi, my name is Andrea Tedeschi, and I'm the System Architect and Pipeline TD at HaZimation. We're a studio that specializes in real-time animation, movies, and games, and I've also been the CG supervisor for our first real-time animated feature film called Rift. This will be an overview on how we achieved many of our crowd shots in the movie using Atom's crowd. For this demonstration, we're going to use a couple of assets coming from the marketplace, like this action male and female pack is a modular asset pack, plus some animation for them, like let's say this one. The idea is we're going to try to recreate a shot that we did in the movie where there is this huge crowd protesting something. So I have several animation of people protesting basically, and we're gonna try to create something like that. Of course, you can use whatever animation you want, whatever character you want, because the process is always the same for every use case you have in mind for it. So whether it is, I don't know, a movie or a game, the baseline process is pretty much the same. First, let's look into the asset that we will use. So they are under Atoms crowd, and we will use an agent type, a variation, and variations, plus Atoms character and state machine. You can create those manually, but there is an automatic way to do it. If you go into Atoms crowd, assets, reillusion, a game pose. So our character is using a real engine for default skeleton. So we use this one, which is actually the Unreal Engine for skeleton. If we have one in T pose, we use this one, but you can also use Reillusion character creator asset, which is this one or this one if it's T pose, and also Mixamo character. In our case, it's Unreal, so we select a game pose and we select the folder. And now I have three assets, an agent type, an agent variation, and Atoms character. So the agent type is basically the identity of our character, of our agent. It includes a skin asset, which is taken from an agent variation, the skeleton of the character asset, and the state machine. State machine is used for animation, and we're going to look into it in a little bit. But first, let's look at the character. The character, as you can see, is basically like a list of the chains of the bones of the skeleton and the retarget base pose. And this is used by Atoms to retarget between different agents with different skeletons. So you have the ability directly from the agent group to retarget between different agents, but also now in a Real Engine 5, you have the ability to use the skeleton compatibility workflow, or if you really want to manually retarget, you can also do that. But with Atoms, you also have the ability to do it directly from the agent group. And the variation is basically the character that is going to be displayed on the screen. And you can add a list of meshes that you want to include for the character. In our case, these characters are modular, so we will need to populate this one with all the parts of the body, let's say a jacket, a head, maybe some shoes. And so you will need to do this for every character. And also there are attachments. So attachment, let's say I want to attach a static mesh, maybe this hat here. I just input the bone that I want to attach to the head in this case. And if it doesn't really work 100%, you have the ability to also apply an offset, so you can fine tweak the position of this attachment to this particular character, this particular variation, and to this particular skeleton. So it's pretty granular in terms of like how you want to work with this. But also there is like another way to create variations, which is with variation builder. Variation builder, you just create one and it's basically randomized between all the part of the mesh that you input here. And we're going to look into this in a little bit. But basically, you don't have to create a variation for every look that you want to achieve. You basically do a graph with this tool and it will randomize between all the meshes, and depending on also the weight that you select, you will have like a better probability to select one mesh rather than another. So it's pretty useful if you have like a load of meshes that you want to randomize. You don't want to spend the time to create lots of variation just for the specific asset. So this tool will come in handy to do that. And then lastly, we have state machine. State machine, as you can see, is basically like an animation view, animation graph. You select a state, you add a state. Let's say, for example, I want to create an idle state. You have the node ID, and this will come in handy later, but basically you can tell Atoms which state you want to use based on this node. So if I want some character to use the node idle, I tell him to use the node 0. If I want to have another state, let's say running, and now this node ID it's 1, I select those variation and I tell them to use this node ID instead. So you can mix and match between different states inside a state machine using the node ID. You have a list of all the clips that you can use. So let's say I want to add one, this one, maybe another one. And there are many settings. I usually leave this by default. I just make sure to not use the clip direction because I want to set the direction directly when I place the agents into the shot. And also I just disable the random loop. If you have this enabled, it will basically randomize between all the clips, and it's based on the weight that you select. So for example, this clip has more probability to get picked up by the randomizer instead of this one. So you can also play with the weight, but for this example, we're gonna just assign an animation and basically loop this animation over and over. If you want to blend between different states, you also have the ability to assign a clip when you move from one state to another. You have like a transition clip to use. So yeah, those basically are the assets that we'll use for this example. And now I will create some variations for the asset, and it's a little bit time consuming, so I will do those off screen and then we'll jump back into it, and we'll also look into the variation builder. So I created two agents, one for male and one for female. I had to create one for the male because it's using a different skeleton. So as you can see, I create a different state machine, different character asset, different skin asset because it's using a different skeleton than the female. And I created 5 variations for the female and 6 for the male. Inside the variations, you can see for the male, for example, for this one, I did add a long sleeve, some pants, some jacket, and I did the same thing over and over to create different looks, as you can see for female and for male. And I also created 2 variations builder. And this will be the one that we'll actually use inside the shot. Now, as you can see, it's basically a graph of all the meshes that this particular agent will use, divided by group. Let's say for the feet, I have just sneakers, but for the head, I have 3 heads. So for each variation, I want to pick just one head. So I did add them into a group and I enabled the use weight. So this will be randomized based on the probability of this weight. And I did the same for the legs, so just one specific set of legs will be picked up. And I went a little bit further with the top because, for example, for the long sleeve, I want to have some variation that are using the jacket and some variation that are not using it. So I created one for enable the weight, and I created added like a crop jacket and an empty mesh. And I also did one for gloves. For example, for the hoodie, I want to have some with gloves and some without. And for example, eyewear, I want to have some without glasses and some with glasses. Let's have a look how to do the variation builder real quick. But there's also, in the documentation, there's also like a pretty good guide, and there are already some videos on YouTube on how to do this, but I will show you anyway. So let's see. Let's create one that is called test variation. You will need to add this one to the agent variations. We didn't look into the agents variation earlier, but it's sort of like just a collection of all the variations that this particular agent has. And in this case, it's like all the variation that I created plus the builder. And let's add uh, the test variation. Test variation, and I call it test variation. Now let's test it. So in the variation, I use the variation asset, and I will use the grid layout component, but in the actual shot, we're using the point layout. But for this one, let's use the base. And as you can see, we have the default agent without any variation applied to it. I increase also the number of agent, and I hide the variations behavior. Now I want to specifically select this test variation for everybody. And as you can see now, everything is blank because there's no mesh assigned to the variations. So let's try to add some. So let's say I add this one. Now it's all torso. So let's add also some pants. Maybe two different. Oh, I added the male, not the female. So female pants. I have two set of pants, the jacket, and the shoes, for example. And the way this works is I will create some group. First, I will create the main group of the character. And let's call it main. So it will always use the sleeve jacket, but we want to use this one as pants, for example. So I'll create another group for pants. And instead of like adding all of them, I just use the weight. And when you enable the weight, it will basically pick one of them inside the group based on the weight. The weight of each mesh is basically the probability of this particular mesh to be picked up. Now, as you can see, some have like jeans, some have not. And I just want to use this jacket. Now, to randomize between jacket or no jacket, You do the same, but you also add an empty mesh. You enable the weight, and now, as you can see, you have some with jacket and some without jacket. So this is pretty much what I did for all these variations. As you can see, I assigned some jackets or no jackets, plus maybe I have gloves or no gloves, and this is for each particular type of the modular meshes that I have at my disposal in this shot. So top, legs, head, feet, all those kind of stuff. Let's have a quick look at the variations and placement and direction. I have this agent variations asset. It includes the agent types and all the variations that the agent type has available. In this case, I just included the builder, but you can also include a specific type if you want. We will look into this in a little bit. So you drag and drop the agent group in the level, and under variation, you just set the variations asset. And we will use the points layout behavior. Now, if you go here under layout tool, you can see that now we have placement available and we have different mode. Point, for example, it will place an agent on the specific point. And I also have random agent type enabled. So this will randomize between all the agents that I have available. But if you want to specify just a specific one, you just click on it. So female like this. And then we have grid. Place them in a grid. Poisson, you can place them like this. And if you look here, we have options specific for each mode. For example, for grid, we can specify how big the grid is. Poisson, if it's like a circle or square. Polygon, for example, you place them in an area. You can specify how many agents you want them to be, like 10, 20, how far apart you want them. Then curve, you place them along a curve. And mesh scatter is scatter this amount of agents in on a mesh that you might have in the level. Now about the direction, if you look at the placement, you can see we have like a little yellow arrow, and this is the direction they are facing. If you do hold down Control, click, and move the mouse, you can see that the direction changes. The arrow rotates, and if you then click, it will face that direction. Now, this is an issue here because your skeleton might have a different axis than the one that the plugin is using for rotation. So the correct way to place the agents is to actually have a state machine always running. So we add the state machine behavior in the group, and then in the layout we can place the agent, and they will placed exactly like we want. This is like the default way and the one that um, is suggested by the guys at Atoms. Okay, so now I have some direction, but let's say I don't want to set them manually, especially if you have a big crowd, is going to be very time consuming. So there is another way to do this. And we have this tool called Spline Actor. We put in the level, and it's just like a spline, works exactly like a spline. So we we create some point for this spline, let's say like this. Can move it a little bit, maybe. And we select the agent group, and we add another component which is called follow target curve behavior. And I can select a spline under the curve. And now, as you can see, they all face this spline here. If I move the spline around, they face the spline. So each agent will face the direction of the closest point in the spline. And now let's start creating the actual crowd for the shot. I will start from scratch and create a crowd that is pretty much on the same line. Points layout. Place like this, for example. I don't care too much about the direction because I will use the spline to set them facing to the same direction. So this is pretty much okay. And then tweak a little bit the spline here. And I select the curve, follow target curve, and the spline. Now they all face the same way, but they use the default agent variation. The way you randomize between them is if you go into Tools, Variation Randomizer, you can select the agent and all the variations that that agent is at its disposal. But for the moment, as you can see, we also only have a builder. But if I add another one in here, say variation 1, now I'm able to randomize between those agents and between those variation, and then I can also specify the probability of one variation to be picked up rather than the other. But as I already told you, the builder pretty much does all the randomization that we can account for. So let's say like this. If I want to have a specific variation just for a specific agent, I just enable on select agents only. And the way you select it is like with select tool, you just drag and drop with the select tool like this. So let's run randomization. And now everybody kind of looks different from each other. And this is a good time to start looking into the metadata. If you look at the character, especially the materials, they all use the same one. And we want to randomize even the color of the materials. The way you do it is using the metadata channel. You have this node inside your materials, which is agent metadata, and it will give you 4 values for each parameter index, and you have up to 7 index. And basically 1 value is a float, 3 value is a vector. And I created this material function that will let you add this to each material that you want to use the metadata. And I created 3 instances. In this case, the skin channel is using the channel 0 and metadata, the first value of the channel 0, basically. So this is the skin metadata. The air metadata will use the channel 1 and it will use the first value of it. And the clothes will use a vector. So we will use for the clothes the 3 remaining channels of the channel 0. So it will be skin channel 0 first value, clothes channel 0 the other 3 values, and then we go to the air channel with its channel 1 and first value. And we have to add this material function to every material. And let's say, for example, I want to add it to the head, and this will be the skin. So you just drag and drop this skin channel function. Oops, sorry. Drag and drop this. The in basically accepts like a texture, and the output it will be the base color. And you have to do this for every master material. So I did one, for example, for the clothes. Should be here. I have this clothes channel here. And you need to create a function instance. You cannot add the master to the material, because if you change it inside here, the value of the function will be applied to this function as well. So basically every change you do will be applied to the master. That's why I just set the instances for each channel that I want to use it, and I apply it to the material instead of driving the parameters from the materials as well. So we add inside the agent group a metadata. In fact, we need to add 3 because we are using 3 metadata channels. And the first one will be skin because it's channel 0 and first value channel 0. So we call this one skin. The other channel 0, other values, it's like clothes. And, oh, sorry, this is the skin. And the skin is a float, so we select double. For the clothes, we use clothes and we use vector for it. And for the hair, call it hair, and it's also a double. And then inside the agent group, you specify the oops. Oh, here you go. It was hidden. So in the instance metadata, the first channel is the skin, then the other values it's the clothes, and the channel, other channel is the air. Nothing changes now because we didn't randomize the values. So, for example, for the skin, inside the double value, you can randomize in this way. You select all, and in the value, let's say between -2 and 2, you click randomize it, and it basically randomizes most of it. I guess -1 is too much, so let's say 0, 0, 2. Okay, so you can see we have different skin tones basically. Some of them are still too dark, so we also have a control in the material function where we can clamp the values. So I don't want to be completely 0, completely dark, so do something like this, 0.2 or 0.5, and it should apply. And now the skin values are a little bit better, so we can also even drag a little bit further, 0.2. And we also have two ways of using this material function. One is multiplying it, and one is using a U. But the U is basically if you have some color and you just set up the U. For the skin tone, we just want to multiply the value of the skin. And we save it. But you can also randomize, instead of using this one, this tool here, this window, you can also toggle the mode here and you randomize here. So minimum value, let's say 0.2 and 2, and you can change the seed this way. Just keep in mind that the override dialog has priority over the added method. Okay, this should be enough. And let's do the same, for example, for the clothes. And it's here. Now this is a vector, and I'm gonna use the randomizer. I'm gonna randomize, let's say maybe 1 to 2, maybe 0, maybe say 3, -2, let's do 1, 0.5, and 2. And now we have like also the materials randomized for the clothes. And I also want to do the hair. So for the hair is the same thing. It's a double. I'm gonna use double for it and the randomizer. And let's say between 1 and 3 maybe. Or between -1, let's say 1 and 5. Or 0.5. Like this maybe. I will try with this. Okay. And okay, now the only issue that I have is that all of those jackets you can see is basically the repetition of the same mesh over and over and over. Even if some color is being applied and multiplied to it, it's a little bit too evident to me that it's still the same mesh over and over. So we're going to create another channel for the jacket. And we first let's do it this way. We first create an instance of the master metadata function, and we call it atoms channel metadata jackets. Now, because the last channel that we used was the hair and it's on channel 1 R, on the jacket, we will use a new mode, and we will use the channel 1 second value. We need to add this function to the jackets. So if we go inside the jackets, let's see. This is using the master for the clothes. So what I need to do is duplicate the master, call it, I don't know, jackets. Need to compile a little bit the shaders. And instead of using the clothes, I will use the jackets. Relink that and save. And let's check also the jacket for the female. So let's relink to the jackets that we created, the master, and relink also. Okay. Now we add another metadata, and this is jackets, and we add it to the agent group. And if we randomize now, everything should work. This is a double, and we randomize between 0 and 2. And now, as you can see, the jackets are a little bit more diverse between each other. Okay, so I'm pretty happy with this now. And what I will do is I will start looking into the state machine and how to make sure that they not clip to the ground, and try to finalize all the animation and the states of the animations. Now let's add animations and state machine. I did create some instances where the agents are clipping the ground. For example, this case and this case, because I want to also show you a way to how to fix this kind of placement issues that you might have. So we add the state machine XPO behavior component. And now all these characters are using the animations inside the state machines that I did set up earlier. So if I hit simulate, they all animate. They pick one animation inside the state and they loop it. So let's fix this issue. You can do it in two ways. One, with the layout tool, you can select and move the agent. But as you can imagine, this can be very time consuming, especially on a big number of agents. So there is another way, and it's using the height field of the state machine. The way it works is using like a collision trace channel, and I did create one called ground with a default response of block. So every asset that uses a physical collision is set to block this channel. And now, if inside the agent group, I can select ground, and as you can see, fix the issue, for example, for this agent. And it also works both ways. I did put this agent too far up, and this one fix it. Now about the states, you can see we have state 0, which is this one, node ID 0. If I want to have a different state, let's say we call it idle. Let's put an idle animation into it. I can also specify the state that I want. So let's select this guy here, for example. I can set the value to 1, and now it's using this other state. So I can have a set of different animation based on the state. So maybe a particular character is angry, another one is happy. It depends on mostly on your use case, but you have the option to also have different states between them. And as always, you can always randomize between all the states that you have. So you can do 0, 1, for example. But I will keep everything at the same state because in my use case, I want everybody to be pretty much on the same page here. Everybody's angry. And at this stage, you do some final tweaking. So let's say I want to fill a little bit this gap here. You try to look if something is clipping, especially with animation that have root motion. You just check if somebody's clipping into another mesh or not. For example, maybe these are too close. They may be too close to each other, so I move like this. And let's fill this gap, for example. Let's do a final test. Okay, so I'm happy with the result. And now let's put everything inside a sequencer. Let's add a level sequence. And let's call it atom sequence. And we add the agent group in. And nothing happens if you scroll the timeline. This is because sequencer doesn't work big in play. And it's also the reason why if you hit simulate, instead everything plays out. There is a solution to this. So in the agent group, you enable static frame. So with static frame, you can tell Atoms which frame of the animation to actually play at the specific time. And now it's using just the 150, and we can animate the static frame. So at frame 0, I want to have frame 0, and at frame 150, I want to have 150. So each frame in the timeline should correspond to one static frame. Make sure the interpolation is set to linear. And now, for example, we are at frame 5 and the static frame is 5. If you move the timeline to a different frame, you can do the same. You don't have to put like, if you're at 30, you don't have to put like static frame 30. You can start at 0, just making sure that each frame is equal to one static frame in the timeline, basically. So we place it like this. And now they also play in sequencer. We can add a camera to it. So let's say I want the camera start from here. And maybe just getting close. And maybe tweaking a little bit the focus of the camera. So like this. And here. And now I have pretty much my shot done with all the variations set in place, the animation, and everything is working as expected. This basically concludes the whole workflow, and now we use Atom's CRUD for the movie. We might have used some additional meshes, some different characters, of course. We also attached some accessory to them, but the base underlying process and setup is pretty much the same. So thank you for watching, and have a nice day.